Bienvenue. Je m'appelle André Arnold. Je fais la recherche en vêtements intelligents avec le laboratoire Vestec Pro dans le réseau Transtech Laboratoire. C'est un vrai privilège pour travailler dans le réseau de la CCTT. I've had the privilege of working all across Canada during my doctoral work, but the expertise in Quebec specifically is what brought me here. And that's not new. Quebec has been producing wearable electronics since the early 1940s. The Eaton Company produced electronic garments for women for toning and trimming and beauty, and the World War II effort produced a large number of electronic garments for heating and mostly heating, keeping pilots alive. And then in the 60s, we start to see a space race. Quebec was involved very early. Le réseau Transtech fait beaucoup de laboratoires, la 49 en ensemble, mais maintenant Vestec Pro fait la spécialisation dans le vêtement intelligent, de uniformes et habillement en ensemble. A lot of the work that's being done here in Quebec, again, it's important to remember this is a very unique context. This doesn't exist elsewhere in Canada. The ability to integrate many laboratories together with applied research, it produces so much value. The translating knowledge from the universities into an industrial setting creates knowledge in and of itself, and a lot of feedback as well. As well, the manufacturing capacity for the uniform sector and the apparel sector in Quebec is probably close to 60% of Canada's capacity. And the level that it's working at, while it has a much lower rate of automation, is very diverse. So there's many opportunities here within the apparel sector and the uniform sector. Ici, c'est un exemple d'une compagnie de Québec, Pixmob. Ça, c'est le cérémonie d'ouverture des Jeux olympiques en Rio. Et tous les pixels là, c'est un individuel avec un petit bracelet, avec la lumière et la petite intelligence. Ça, ce n'est pas une technologie, ça, c'est un spectacle. Et comme dans le monde du cirque, Québec est absolument dans la vanguard. Quebec is defining how these things are done. And I think this is a good example. This isn't a lighting system lighting up a crowd. This is a technology that's giving people an experience. And that's an aspect of technology, the social and the cultural aspects of it, that are still really the foundation of a good business case. The technologies themselves were invented here, and they have a huge R&D team, 70 employees, about half of which work in R&D specifically, and this team is doing stuff on a very tiny budget in terms of the cost per unit. They're producing millions of pieces of technology a year, very quietly, because they're interested in the experience more than the technology that they produce. Mais le concept de vêtements intelligents et le wearables, ça c'est un problème. It is very difficult to define. We can look at different generations of technologies, ways of attaching sensors to apparel, embedding them inside the apparel, integrating different properties of the materials to create different kinds of sensors. But most importantly is, at this point, and again, jumping over the IoT model, which is kind of like third generation, you know, where you're starting to integrate it all, is the cyber-physical systems. And that's very relevant because Quebec's expertise in manufacturing and automation has caught a lot of attention. We see interest in Germany being able to partner, for example, with Quebec to demonstrate a lot of these advanced automation technologies, the Industry 4.0. At the heart of it, though, is cyber-physical systems, where we can begin to integrate a large degree of security and intelligence into apparel by having them modeling systems in real time. You know, a cyber-physical system is monitoring a physical process, creating a virtual copy of the physical world, and making decentralized decisions, much like people do. Again, they will break, they will fail, they will fall down. But we can see many examples here where we can begin to work with the different layers and to individualize it for applications. These technologies here is a product by XSense, a Dutch company for motion capture. A large amount of their work is done in industrial settings for automation, efficiencies, coordinating human beings with robots, improving work environments, changing workflows. And then, of course, elite sports and entertainment. Again, these are all things that Quebec is very established in. While Quebec has a low rate of automation, Quebec also is the major supplier of automation technologies to the rest of Canada. So I think there's an interesting opportunity here where some very smart decisions have been made for a long time. And this is an example with the cyber-physical systems where by integrating many specific disciplines into specific product categories, we can continue to produce the next generation of products that are not being developed elsewhere. At the heart of all this, dans le mandat de Vestec Pro, avec l'uniforme, le vêtement intelligent, et abonnement, et le mode aussi, is the body. The human beings are what holds all this together. And there's many sciences and even a lot of arts that go into building a wearable system. There's a lot of ways where you have to factor in social and cultural and environmental aspects of being on the body that are very different than anywhere else one might put a technology. You might have a little Bluetooth module. As soon as you put it on the body, you're going to create completely different problems for it than if you put that in a child's toy or if you put it on your wall, in terms of how it communicates and what kind of data it gets. It's very difficult to put technology near the body. The body is a source of noise, a source of disruption, a source of signals. But are they good signals or bad signals? It's very difficult. If you're working with anybody who's developing wearable technologies, the best question of whether or not they're doing it well is if they have an expert in physiology within their team, or if they've done a very large amount of physiological evaluation. Each physiological signal is very specific and has many types of problems. So once you, and to gain good signals, you need to have many different types of physiological signals to be able to effectively categorize your data. So being able to check for the physiology expertise is something to look for. Again, here in Quebec, there's many laboratories working in the different aspects of that. So this has given Quebec a very large advantage in terms of developing these technologies. Many of these university experts here are already working closely with industry. Now, the big question is also intelligence. Avec le vêtement intelligent, pourquoi intelligent? That's a good question because no one has effectively defined intelligence for anybody yet. Now what we can do is we can look at different levels of feedback. We see no feedback, a very simple device. It doesn't even have a light, it just collects data. Maybe it streams it, but there's no interaction between the user and the data. Limited feedback, maybe there's a status light. Contextualized feedback, it's a status light, but it's also checking your GPS coordinates. Those progressively can allow very sophisticated interactions if they're very well designed. However, the computing power that's required to do the basic actions that a human being does just walking across the room would take a whole server farm to be able to have a robot moving like a human being. As we're seeing more and more miniaturization, but many of the skills that human beings have are the most essential markers for what we would consider intelligence. We evolved them, and it took us millions of years to evolve them. And there are ways to actually implement those into the technology. So human-based computation it's a concept, it's a construct, we work with it, but what it means is we can actually offload a lot of computational processes onto the human being using design. And it's not just a technology necessarily, but it really is a design process that can be utilized. It can be optimized in some cases, and it certainly has its limitations. But it's a very large part about what happens next with wearable technologies. And even in professional settings, even if they're not wearable, using human-based computation to basically have the computer offload specific tasks that are too computationally intensive onto a human being. We're seeing this being used already in certain settings for very specific cases. And it allows us to, we can work with these first 3 layers of feedback to create very sophisticated technologies. If we can get human beings in the loop, we can actually augment our existing technologies to make big leaps forward into new niches, new applications, or new business models. The quality of wearable computing is a very big problem. Most of the technologies that have been built don't exist. Here we see an example of a vest that's used for 3D mapping of heart activity. This is the same sensor as someone might have in an Apple Watch, or have on a little finger sensor, or a clip on their earlobe. And this gives us a reference point to contrast. This is what a good signal looks like. It's an actual collecting many elements to produce a good signal or a usable signal. It doesn't always have to be like that, but this demonstrates the contrast between the 2 extremes. A quick checklist though is, I can give you 5 points, very quick points, for how you can tell if you're getting a good signal in terms of quality. The first is fit, the physical fit, how well a sensor is fitting on the body. It's a layer of signal pre-processing. The physical structure, the quality of the fit, the conformability. it actually will do more to improve your quality of your data than any filter you can put on it afterwards. That's an example. So the fit with the human body, and again, that's very specialized. Importantly, that's also an area, anthropometrics, 3D scanning, and fitting and patterning technologies. That's an area where Quebec has advanced expertise in contrast with other provinces and other regions. It's a strength of the Francophonie in terms of the textile and apparel sector, and a lot of the science and technology in the area is available to utilize for computing and technology development. Another aspect is diversity. I mean, here we see repetitions of the same sensor over and over again, which is good. It means that you have a lot of signals of one kind. But even more important is being able to correlate many different kinds of sensors, 2, 3, 4, 5. Each different type. One might measure respiration, one might measure heart rate, another measures temperature. Individually, each one of those data sets, you can categorize with some certainty the signals, but once you begin to cross-correlate between them, that's when you create a robust signal. Some modalities like temperature might only improve your categorization by a few percentage points, but that can make the difference. We have to remember that things like speech recognition, when it was introduced in the 1980s and 1990s, it wasn't actually usable until it reached 97 to 98% accuracy. Signals below that aren't practical for most day-to-day applications. And again, as we see here, another strength, another asset to look for is numbers. Repetition, so you have arrays, so you have your redundancy. That creates a huge benefit for improving the quality of the signals. Another aspect, well illustrated also, is the feel. So I talked about fit on the body earlier. The feel is incredibly important. And that's not just physical. So comfort is very important, but also social in terms of people's willingness to actually wear something or use something. There's a kind of a joke in the brain-computer interface community. It's called the bucket theory of brain interface. Most people who need brain interfaces, for example, are paralyzed, have a degenerative disease, maybe a serious spinal cord injury. They can't move their bodies. They want a tool that can allow them to turn the lights on or drive their wheelchair or communicate. They'd be willing, if the technology worked, to put a bucket on their head. It would be, to go to an extreme, they would take a very inappropriate form if it gave them the benefit. Few of our technologies actually give the benefit that would allow people to overcome the social pressure of a technology. Nobody wants to wear something on their head, wear something strange or bright or loud, except for children, maybe. But that being said, the feel is very important. Sensation on your body, but also how it makes you feel about yourself, how it makes people around you feel. And that's something you can begin to measure it incrementally, but even as a reference, it's a good way to filter out ideas early on. And the last point in terms of the 5 basic points for assessing quality is qualitative. You need qualitative data to contextualize and calibrate your quantitative data. The quantitative data is not enough to be usable in most clinical applications or most applications that require careful categorization. If you always make sure that you include, at least during different stages of your algorithm development and your data collection, if you can also collect a certain amount of qualitative data about, well, what were you thinking, or what time of day was it, or what was your mood, or did something happen before the test that caused those strange numbers? There's many standard ways to do it, but there's also informal ways to do it. Always leaving room in your development process for some qualitative data will help identify opportunities and help reduce risk. And this is the risk, is that with wearable technology, there isn't an umbrella. Ce n'est pas un parapluie de wearables. Each one of these, this is a project, a periodic table of wearable technology. It's a group in the US. Each one of these is a very specific, narrow application of wearable technology. Is it complete? No. It's kind of a joke. But each one is a very specific, narrow application, which is based on evidence and based on market research and based on products that they're selling. Each one of these is different enough from another that you can't take one and put it into another spot. They are like elements. Ici, en Quebec, c'est le même. We find that with any aspect of wearable technology, it's very specific, highly, highly individual. And particularly in manufacturing and industrial settings, one company compared to another, one mine or factory compared to another are going to have slightly different requirements. You can create some commonalities, and you can create strategies like creating platforms. But in terms of business development, finding a generalized solution is very, very limited in terms of the ability to scale it up. You're much more likely to find a narrow solution and then apply it to multiple customers who have a narrow requirement. This is a neural dust mote. Now the concern with the electronics disappearing is, and making them invisible, is that people will forget they're there. But I don't think that's very likely. These things are still very invasive. Even a technology like this, in order to actually effectively use it, it's going to cause all kinds of inconvenience at the level of construction of garments, end of life cycle, durability. But we are seeing trends. The materials are already here to be able to integrate the basic sensors into apparel. They're small enough to be usable, particularly in industrial settings. That isn't a limitation now, because here we have the skill and the technologies to integrate solutions that are small enough. That is not necessarily the case everywhere. There's a number of specific labs in the US, for example, and a couple else across Canada. But in terms of the competence required to miniaturize them in the correct form, the correct materials, in the right quantities for the right clients, the right suppliers, that capacity is here. It's not something that we have to wait for, but it's something that requires many different people to contribute to actual miniaturization. This is an example of what a good signal looks like, or certainly how we collect one. And this is also really the ultimate application. If there's a general application of physiological signals that are collected from wearable computing, this is an example of how it's done right now. And it also shows how a good signal is collected. Is this usable? No. But this is how we collect data to develop the algorithms, to provide baselines, to then try to calibrate other applications. Physiological computing or affective computing, they have a lot of value. They can be used for affective video games. They can be used for neuromarketing processes. But again, these are more for controlled clinical settings, maybe even basic research in the university setting. But this is what we see as an important part of the research cycle to allow people that are doing more consumer-oriented products or more industry-oriented products for industrial settings. This is the work that's already happening here in Quebec. The world's largest manufacturer of these types of equipment is here in Quebec and has been here for over 40 years. This is something that takes highly specialized work to do properly. That already exists here. Now the question is, once you have this as a baseline and then you begin to develop the products around that, that's a whole bunch more work. But this foundation is there to support any further development. And it's available and accessible here. But this is more important. This is, frankly, the future of wearable computing. And I say that based, again, on the technology here. Several years ago, I was doing studies. We're doing market research with the world's top elite sport clinics. And we asked what the proportion of male to female clients is. Because we're looking at neurofeedback and biofeedback technologies, very similar to the consumer technologies, wearable technologies you know. With just a few extra lines on our questionnaire we included, we're asking about the ratio of men to women. What we discovered surprised us. The only place that we see a 50-50 relationship of men to women, 1-to-1, is in elite Olympic level sport. In every other application with neurofeedback, biofeedback, we're seeing 60 to 70% of the people who are using real world technologies which are proven effective clinically, we're seeing women are adopting them, are using them properly, continuing to use them, and then upgrading to new technologies or gaining continuity. So, and in general, there's probably a number of explanations. I could only offer a partial explanation. There's not enough study or research been done into this, but the demographics are very different than what we think. Being able to produce products for women, and certainly coming from the apparel sector, products that are produced with women involved, is a major priority. In fact, what we see right now are many products or technologies that are developed, wearable technologies. They don't take off, they don't work, they take these long development cycles, and in many cases they fail. Or in some cases, like Quebec's Signal, they nearly fail, and then they drop their entire product line and only produce products for women. They save themselves by doing that, but if they'd done that 3 years earlier, their investors would be much happier. So this is a trend that we see. It needs more study, but it's very strong evidence, based on surveys at least, that this is probably the trend in terms of successful market development. We're seeing it partly as better awareness of body comfort and body fit for products, so women are producing better signals, but they're also doing a better job of contextualizing the data. So there's many good sort of management or behavioral traits that go along with it, but it also indicates that people who are able to identify very good applications for products for women may actually be able to make a stronger business case, at least at this point, in terms of being able to gather evidence for the profitability or the success of a product. So it's an important consideration, as well as women doing development in these technologies. Having women or partners who are involved in the development cycle very far upstream, including with electronics, it can be a very large asset. This is the other major question, and I think this is something that speaks to the unique capabilities of the industry here in Quebec. The major problem with the adoption of wearable technologies is that it's very disruptive. We see a lot of marketing and advertising being driven now by physiological sensing technologies and clinical studies and neuromarketing techniques, like I mentioned previously, where they're looking at physiological responses in more of a clinical setting to establish how people interact with media, how they can be manipulated more effectively, creating different models of different segmentations of the types of users. But this also creates all kinds of problems ethically. Especially if you can collect data from people in real time or collect it from populations, especially if you're accessing data surreptitiously, especially if you're also using it to manipulate electoral outcomes, for example. Now, what kind of data are you collecting? It doesn't necessarily matter. I mean, it might not be much more sophisticated than the click of a computer mouse, but in other cases, you can collect very fine-grained resolution data using non-invasive technologies, getting heart rate and respiration from simple video streams. This is important because what we also forget is going back to, again, to the 1940s and 50s, is the earliest technologies really are lie detection technologies. So the ability to detect falsehoods, to be able to detect the veracity of statements, this is something that requires a social and a cultural response. It's not something that should be dealt with simply, because there's a lot of room for large entities to manipulate smaller entities, or large entities to manipulate a large number of smaller entities. That's a very large generalization. It could happen at the level of one company with a manager who has access to everybody's wristband data. It can happen at the level of a government negotiating with multiple unions, for example. You have a bunch of blue-collar guys, or maybe people who are air traffic controllers, people with unions, police unions. They have to know how the data that they have on their workers is going to be used if they're sitting down to negotiate a contract. It's very disruptive and it's very dangerous. So a lot of the questions around that are open questions. There hasn't been a federal level response to this. There's a lack of regulation. There's a very high level of risk. At the same time, I would say that probably here in Quebec, there's a much stronger likelihood of being able to begin to conduct formal research and actually establish some standards and regulations in this area. That being because Quebec really has been one of the first cities in the world to work in this field. Again, going back to the 1940s with the Eaton Company, with their work with wearable technology. But even in the last 10 years here in Quebec, in the last 20 years here in Quebec, it's been at the forefront of electronic textiles. It's been at the forefront of wearable computing. What we see as a large wave right now with apparel-based sensors, not just simple wristbands, is really work that's come out of Quebec, and largely it's come out of work that's been contributed to deeply by the Réseau Transtech. The Applied Research Centers, the GCTT has made its contributions, Vestec Pro has made its contributions, CIMEQ has made its contributions, CIMEQ, I believe, has made some contributions in this space to some degree. This is something that's happening in Quebec with applied research. And again, that ability to not just look at the different companies who are doing it and the different researchers, because there's a large network of those here. What there is also is an ability to actually make a, you can call it lobbying, or you can call it simply an intelligent set of decisions. But it also is a way for Quebec to define a number of standards in this area. They don't exist. Quebec is much further into this. Because it's apparel-based, because it's textile-based, the Francophonie is much stronger in this domain than the English-speaking 80% of North America. This is something that Quebec can make a very unique contribution to change something maybe, but more importantly, establish something new. The regulations aren't here. There's room for industry and the many different industries who are involved, because it's easily 6 or 8 major industries required to produce a wearable technology in terms of the textiles, the patterning, the software, the firmware, the hardware, and then the nano components in terms of some of the treatments and so on, and then many more. the whole life cycle of these products means that we're in a position here to actually negotiate and define some of how these products are used. But it also means that we can also, by doing that, we can also establish a large pool of intellectual property by moving into this area first. We're already there. The question is how do we want to define that? There's room for entrepreneurs, but there's also room for the government and for industry to really significantly change how this technology is adopted around the world by simply having a conversation here in our own homes. So, a couple quick examples of companies here in Quebec who are working in this area. These, we have Ohm Signal, we have Hexoskin, and we have Hidoko, and then also Sensoria with their smart socks. These are technologies that people are using. They are technologies that were made to very carefully function and produce good signals so they would be useful. And they're technologies that do one thing well, and that is they can be worn and they can be used in a way that the person who's wearing them is going to get a benefit from them. They're not wearing them to be seen, they're not wearing them to be famous, they're wearing them because they offer a benefit. We can see those same technologies going into industry. We can see those same technologies going into maybe even more actively into health as opposed to just wellness. And I think we're going to be able to continue developing. The capabilities here, the technologies are here. The biggest contribution potentially really is the ability for Quebec to define the future of this technology. The Quebec is ahead of the rest of the world, and it's not just diving at the Olympics, and it's not just downhill skiing. It's a competition that's based on competence. It's not a coincidence that Quebec has done this. The question is what can we do next? Merci beaucoup. Est-ce que tu as la question? Je suis prêt pour la question en français aussi.
What would be the next step in the wearable? Because you just showed some of it, which is electronics apparatus on top of Mote.
Yes.
What's the next step?
The next step is embedded systems with enough processing power on them to actually remain secure in a real world setting. Probably data security is the next step, and some standards around that, and those are at the level of hardware and at the level of software. As an example, I mean, we do know that the electronic textiles are a major next step for the whole sector, but within that context, the ability to actually keep data secure on the body is the major step. Because it's not just technology, because there's many good technologies to achieve that, but what there aren't is a standard. And the ability to actually have the blue collar union, have the police unions be able to say, yes, we would allow our members to use that, even if it's just for training, or if it's just for specific exercises, being able to use that would be a major accomplishment. But to do that, we have to protect employees from their employers, or protect individuals from the corporations that they're negotiating with.
Or insurances from people.
And that's the main concern. Now, at the same time, the insurance companies may be one of the groups that would help support the development of standards. But I think we can also say very well that probably the unions should be more directly involved in initially establishing what the risks are.
For the certification, is it a medical device? Or?
Some of them are. A lot of them are also ISO 60601, so kind of a wellness devices. Very little study has been done in this area, but many products have been sold for a long time. So we look at a lot of biofeedback and neurofeedback technologies. They're interesting, they're functional, but when you really look at their performance, it's very hard to construct good studies in this area. No one group has put a lot of studies into it. And frankly, I see limited benefit in many ways. Individually, they can have incredible benefit. That's the thing but as a group, the regulatory framework isn't necessarily correct. A lot of these are sort of in between a medical device and a toy, and they have a category for it. I think what we need to see is probably regulatory frameworks for implementing these more towards productivity and safety. The health aspects are very strong, but a lot of it is hard to assess for. And I think a lot of the benefit as a medical device is very varied. A good example is a lot of people, men and women both, will use these kinds of technologies for incontinence training, for biofeedback technologies specifically, not a wearable, but the same type of electronic where you're training someone to reuse an injured part of their body following a surgery or following childbirth. These technologies work very well for that, but they're very hard to say that they work for everybody. They work for some people very well, and less so for others. I hope that's enough of an answer.
I saw your graph that you were showing that the smart textile are going up on the market. A lot of people are talking about the hype of wearables, that we could be in some kind of bubble.
Yes.
Bubble.
Yes.
Do you think there's going to be a drop into market of smart textile, or we should still go up on?
I think the textiles are. And the textiles and the wearable, the textiles probably have a lot more applications. They can continue to diversify into many industrial sectors in terms of geotextiles with intelligence and different kinds of structural textiles for transportation or construction with intelligence. On the body, the only way we're going to move forward is by, again, I'm very skeptical about any kind of exponential curve. I think any growth we see once you control for variables is very linear and gradual. Which is to say the only way to actually continue growth is to have a reasonable approach to creating hundreds or thousands of very specific applications. The value is in the applications. We don't need big data, we need good data. And the only way to get good data is to create a controlled application. So if you say, look, I've got a wearable, it's perfect, it's for train engineers who are operating big trains going across the country around the world, and it allows them to do night shifts and stay alert more safely. And it just does that. That in itself is like, well, it's a high-end niche market. So if you can actually just create a product that works, you're not going to spend a lot of money on marketing it, but you may only have 10,000 sales a year internationally, or 1,000. But you'll have a very high profit margin. For a company to do just one product like that, it's difficult. But for a company to do 100 products like that, you're going to employ a lot of people, you're going to push a lot of paper, but you're also going to make very many high-end products. Each one of those, again, doesn't need big data. It needs good data, because the value is in the patenting of algorithms that are specific to an application that are created from the data you have. I've heard similar things being said already today, and I agree with practically everything I've heard today. Again, ethics has come up, but also the need to create very focused approaches and algorithms from data that aim at applications.